Captain Peter Cutsey, Part 3, Adverse Weather, Cold Operations. In Belgrade, we've executed the RNAV approach to runway 12. We went around and we're now on a holding pattern, as you can see, at the Belgrade beacon. We will get right into PowerPoint, slide summary, and we're going to discuss engine operation in flight. This is all from the FCOM. Engine anti-ice operation in flight. Engine anti-ice must be on during all flight operations when when icing conditions exist or anticipated, except during the climb and cruise when the temperature is below -40°C. Engine anti-ice must be on before and during descent in all icing conditions, including temperatures of -40°C SAT. When operating in areas of possible icing, activate engine anti-ice before entering icing conditions. Warning, do not rely on airframe visual cues before activating anti-ice. Use the temperature and visible moisture criteria because late activation of engine anti-ice may only allow excessive ingestion of ice and result in engine damage or failure. Caution, do not use engine anti-ice when the SAT is above +10. When engine anti-ice is needed, engine start switches, continuous, pilot monitoring. Engine anti-ice switches, on, pilot monitoring. Verify the cowl open lights. The cowl valve open lights illuminate bright, then dim. Verify that the cowl anti-ice lights are extinguished. Well, let's have a look at pictures for engine number 1 and for engine number 2. Note, if the cowl valve open lights remain illuminated bright with engine at idle, position the APU bleed switch to off and increase thrust slightly up to a maximum of 30% N1. Also, don't forget to check the TAI annunciation visible after selecting engine anti-ice on. So you select the engine anti-ice switch on, bright, and then dim, and then go down to the upper DU and check its respective TAI light, and then repeat that for the number 2 engine. When engine anti-ice is no longer needed, engine anti-ice switches off, pilot monitoring, to verify that the cowl valve open lights illuminate bright, then extinguish. Engine start switches off, and that's pilot monitoring. For wing anti-ice operation in flight, ice accumulation on the flight deck window frames, windshield center post, or on the windshield wiper arm may be used as an indication of structural icing conditions and the need to turn on wing anti-ice. So when you first start seeing it actually on the wiper blade bolt, when you start seeing a little bit of white at that point, that is your best indication on the 737. In flight, the wing anti-ice system may be used as a de-icer or an anti-icer. The primary method is to use it as a de-icer by allowing ice to accumulate first before turning the wing anti-ice on. This procedure provides the cleanest airfoil surface, the least possible run-back ice formation, and the least thrust and fuel penalty. Normally, it is not necessary to shed ice periodically unless extended flight through icing conditions is necessary, such as in a holding pattern. The secondary method is to use wing anti-ice before ice accumulation starts. Operate the wing anti-ice system as an anti-icer only during extended operations in moderate or severe icing conditions, such as a holding. Caution, do not use wing anti-ice when TAT is above +10. Caution, use of wing anti-ice above approximately flight level 350 may cause bleed trip-offs and possible loss of cabin pressure. When wing anti-ice is needed, wing anti-ice switch on, pilot monitoring. Verify that the left and right valve open lights illuminate bright, then dim. When wing anti-ice is no longer needed, wing anti-ice switch off, and that's the pilot monitoring. Verify that the left and right valve open lights illuminate bright, then extinguish. Well, let's go and do that. We're in the holding now. Let's move over to the respective panel. We've got the engine anti-ice on, as you can see. So we'll go ahead and move the engine anti-ice switch on, and we'll notice both bright call valve lights went bright, then dim. Now let's say we're out of cloud and we no longer require them. Bright, then extinguished. All right, so a picture is worth 1,000 words. Let's go to the last item of this briefing, called fan ice removal. Caution, avoid prolonged operation in moderate to severe icing conditions. Prolonged operation in moderate to severe icing conditions can lead to blade spinner icing and engine vibration. Severe icing can normally be avoided by a change in altitude and or airspeed. If flight in moderate to severe conditions cannot be avoided, do the following on both engines, one at a time. Now, this procedure is in the supplementary procedures. Note, engine vibration can reduce to a low level before 80% N1 is reached. However, thrust increase must continue to a minimum of 80% N1 to remove ice from the fan blades. So we'll assume that we've got an engine vibration, then it's not over 4.0. Engine vibration can indicate full scale before shedding ice. However, this has no adverse effect on the engine. Now, before we go ahead with the supplementary procedure, which we are about to continue, let's ensure what is causing the vibration. As in everything that we do in an aircraft, if we experience an engine vibration, we must follow the QRH procedure if there is one. And in this case, there is a QRH procedure. Engine high vibration is that procedure. Now, high vibration is classified as greater than 4.0 units. Greater than 4.0 as indicated by the QRH procedure. So the supplementary procedure will lead us to the QRH procedure if required. So let's just say we have a vibration, we feel it, we check the vibration units, but the vibration is well under 4.0, so we can go ahead with the supplementary procedure. Fan ice removal. Engine start switches both, flight. Auto throttle, if engaged, disengage, pilot flying. Thrust, increase, pilot flying. Increase thrust to a minimum of 80% N1 for approximately 1 second to ensure that the fan blades and the spinner are clear of ice. Thrust reduce as needed for flight. That's the pilot flying. Wait 15 seconds. Both of you punch your clocks. This allows engine vibration level to stabilize. If engine vibration is less than 4 units after thrust is reduced, repeat the above steps at approximately 15-minute intervals or sooner if needed. So the key is 4.0 units. auto throttle. If needed, engage, pilot flying. If engine vibration is 4.0 units or greater, after thrust is reduced, do the QRH engine high vibration non-normal checklist. Well, let's just go and have a boo at that now and see what it's all about. And if you notice, I've highlighted them. Engine high vibration. The vibration level is 4.0 units or greater. So that is the deciding factor whether you do the supplementary procedure first or the QRH item first. If your vibrations are less than 4.0, you're in cloud, you know you're in icing conditions, it is probably the reason for the vibration is fan blade icing. All right, let's just have a look at this. If we're 4.0 units or greater, choose one. In icing conditions, go to step 2. If you're not in icing conditions, go to step 8. So step 2 takes us through something very similar to what we've already done, except it's returned to 45 seconds N1 for 5 seconds, then slowly advance to a minimum of 80% N1 for approximately 1 second. So very much similar to the supplementary procedure, but remember, we're not going to be going into the QRH procedure unless we're 4.0 units or greater. So then you would follow the QRH, thrust lever reduce as needed, wait 15 seconds, and this allows the vibration to stabilize, and then choose one. Vibration level is less than 4 units, continue, normal ops. If vibration is greater than 4 units, go to step 9. Auto throttle if engaged, disengage, thrust lever affected, engine confirm, retard to maintain vibration levels below 4 units or until the thrust lever is closed. Now, note, do not use FMC for performance. Now, they don't say anything about shutting down the engine. Now, there's a little note here. If the vibration indication does not decrease when thrust lever is retarded, it does not go into shutting down the engine. This is an airmanship function. If you're going to shut down the engine, you have to have a good reason to do that. And if you follow the checklist through everything and you still decide that you've got other parameters, and with the experience of your captain and first officer discussing this together, you may indeed do a shutdown. However, follow the checklist. If you're going to shut the engine down because of this if statement here, if say engine indications are not normal, then you can decide as a crew whether you're going to shut the engine down or not. All right. So that's very important. So that actually concludes this part 3. We're going to get into part 4 in the next video, where we'll be discussing temperature or altitude corrections due to cold air temperatures. Thanks for watching. See you in part 4.